Welcome, welcome. Now, today, what we're talking about? We're talking about how these are the game's worst enemies. Are you also having problems with your water pumps? Are beans also standing on top of them? Well, today, we are solving all of those problems. Hey. Well, problem number one. Dealt with. Now, after that, let's look at fluid dynamics and see how we can actually make sure that you get 100% flow rate. And we'll be going through some of the basics of how pipes work and everything. If you're a new player, stay here. If you are a more advanced player and you know the basics of like how fluid dynamics works and what different parts you have to play with, and then skip ahead a little bit in the video and you will find where we actually start talking about how to fix flow rate issues and stuff like that, and countering the Mark II pipe bug and all of that kind of stuff. So let's get going. Okay, so if you have just unlocked, like that's probably where you are. If you're looking after this video, you're either someone who is having problems with like the massive flow rate issues with the Mark II pipes, or you're the kind of person who are new to the game and just unlocked coal power, and because of that got access to water extractors and the first mark of pipes. You got some weird parts now that you don't know really how to use, and like the coal power plant keeps shutting down, or like it doesn't actually get all the water that it needs for some reason, or it doesn't start at all. Worst case scenario, right? So how do we fix this? How do we figure this out? Well, first we gotta understand how fluid dynamic works in the game compared to the normal belts. Because if you look at a belt or a conveyor lift, let's look at these. They can only move in one direction. That's not true for the pipes. Water can move in both directions at the same time. And depending on which flow rate direction is the higher, that's the direction the total water amount will flow. So these pump out, completely overclocked, 300 cubic meters per minute. That's a full Mark II pipe, right? When they combine here. But if I had a 900 value, like no, the pipes doesn't allow for that volume. But let's say that I had a 900 value pipe over here pumping in the other direction. What I would get is a flow rate 300 in this direction, and everything else would be neutralized. So that's something to keep in mind, that water can slosh back and forth in the pipe. It's not limited to you going like, yeah, but I set out the pipe this direction, shouldn't it move that direction? Water doesn't move like that. Water does not care. It actually cares about gravity. It cares about the total flow rate. So you have to think about head lift and all that kind of stuff as well. Like, can you actually lift the water up? If you open these, they will actually tell you. No, wait, they don't. Sorry. What you do have when you're going up is head lift. And you gotta like figure that bit out as well. All of that, I will tell you how it works. So let's start with the parts. We have pipes, Mark 1 with or without an indicator, the indicator being this little bit. And if something is pumping water, if I empty this pipe, and you see it starts pumping water, you will see that it starts moving. This is an indicator that water is actually being pumped through the pipe. And then when water is not moving, because it's full or whatever reason, it stops like this. If it's empty, it stops like this. Okay? So that's the indicator, and that's the Mark 1 pipe. They move a total, like a maximum amount of 600 cubic meters of whatever liquid it is per minute. And then you have pipeline Mark 2, and that's it. For belts, we have 5 levels of it, right? But for the pipes, we just have these 2. We also only have 2 levels of pump. We have the Mark 1 pump that you have just unlocked, which gives you a head lift of 20 meters, right? And that means that you can move liquids 20 meters straight up into the air. And then you can go up and down with stuff like that or whatever, but the maximum head lift because of this pump is 20 meters. And then you have to add another pump to keep going. Okay? So other than that, you have unlocked this, the junction cross, which is simultaneously a merger and a splitter. Because like we said, liquids can move both directions at the same time. So if you move something in here and it splits out, you have two going each direction, and then they circle around and go back in, the water or liquid coming in from this direction will once again be calculated with the other water, and if it's too much, let's say that you have another water extractor over there that ups the total amount, and it pumps back in here and it's too much, then this entire pipe will back up and water will flow the other direction instead. So keep that in mind. And you have the fluid buffer, the bane and savior of all fluid dynamics. If you don't know how to use the fluid buffer safely, don't use the fluid buffer at all. I will get to later when we get into fixing flow rate issues and stuff like that, how to use these. And then you have extra stuff like these floor holes. You have a bunch of different supports that you can use to stack pipes up very quickly. You have wall supports, that means that you can place pipes on walls and similar stuff like that. It's literally just like extra logistics stuff. One thing that I will state, and it's why I placed this one out here and not the other ones, it is that this is bugged as hell. If you get problems in your system, this is the reason, or these valves are the reason. Valves are unlocked together with the Mark II stuff. This is the Mark II pump as well. This can pump up to 50 meters up, so it's more than twice as effective. And the less valves, the less pumps, and the less floor holes you have, the better and the less buggy your experience dealing with fluid dynamics that are already hell to deal with on their own, you will have. Okay? So, that is it. The fluid buffers come in two sizes. 400 is as in it can store 400 liters or cubic meters. I think it's liters. And then 2,400 in this one. Okay? I think it's cubic meters though, like because that's all the other units. But 400 and 2,400. So this is 6 times more effective than that. And that means that, but it doesn't take up as much space. However, this needs heavy modular frames to be built, which means that you need to have automated one of the harder items to automate, especially if it's your first run. Then I would recommend just sticking with this, because you don't necessarily need these big ones unless it's for very specific reasons. And yeah, other than that, I have shown before one of my favorite blueprints to do when I'm moving liquids, as in having a fluid bus, is building like this. That, like I said before, the floor holes can cause problems, especially when they're placed in blueprints. So one very good way of getting around that and not having to deal with it is don't use them. Build like this instead. This creates an automatic, very natural, like almost like a valve. It will prevent backflow so that when liquid goes ahead, it hits this fall and it won't be able to climb back up. Or rather, even if it could climb back up, even if you do have the head lift, liquids prefer going down, which means that it's very unlikely that it will go back up unless something happens further down the line that pushes things in the other direction. And we'll get to that in a second. So, what different kinds of like manifolds or like connections can you do with this? Well, we have a bunch of different here, and I will go through them in a second. The easiest one to do, especially when you're working with your first coal power plant, is you can just do this. It's a very simple manifold, so that the liquid would come in like so, right? You can see that it starts pumping, and it just goes in and it splits off. So of those 600, 300 goes there, 300 goes here, 150, 150, 75, 75, and so on and so forth. And then once that gets filled, more gets flowed down, blah, 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 all the way down. Meaning in the end, you have everything filled up, everything running smoothly, unless you get flow rate problems. And then we are looking at specifically head lift, okay? And I will talk about that later, but we are going to be looking at water towers. So when you're dealing with liquids, if you have head lift, let's say that this can lift 50 meters, right? There are 5 4-meter foundations, which means this is 20 meters up, and it can lift in one go all the way up, right? That means that this now is the maximum head lift. So if you build a factory on this end that requires water, right? As long as you are not trying to lift the water again above this level, you will always have the head lift needed in that factory, which means you don't need more pumps, you don't need like more valves, fluid buffers, or anything like that. It will just keep flowing down from this point and push down and make sure that you have no problems with head lift. Okay? So keep that in mind. So that's something that is very common, and a lot of people, like advanced or not, they do this to not have to use any of the pumps and make moving fluids around in their factories very, very easy. Other people, like you can see over there, there's a tall as hell waterfall. If you build your water collection up there, and then you build your factory down here, just run it down from the geography. You don't need to use the foundations for it. So that way you have a natural way of running liquids down instead of having to like pump them up first. So if you start your water collection high, just run it down to where you need it, and you're gonna be fine. So that's one very simple way of not having to use any pumps at all. You just have your water extractors. They go over the waterfall and then down, and then it's fine. And you have multiple places like you have down here. I've seen some people build. You have down in this gorge. There are a lot of people who collect the water up here and run it down this waterfall and build their first coal power plant over here because there's a lot of coal. And there are a multitude of different things like this you can do to not have to use pumps. So yeah, that's something you can experiment with, and there's a lot of videos on YouTube to show it. Now we get into fixing flow rate issues, okay? So there are 2 major problems when you're dealing with pipes, especially the Mark II pipes. For those who know, they are using floating number tables, or floater, I don't remember exactly the name, but they use floating number tables for calculating the pipe volumes, and that causes instability the higher the volumes you're dealing with are, and or inaccuracies in those calculations. And these things are constantly being calculated. However, they are being calculated per pipe segment, right? So if you do like this, and you have 4 pipe segments on a small strip like this, that means that this has to be calculated with what's coming in, and then it has to be calculated here for what's coming from this to this, and then it needs to be calculated over here to what's coming into this and this, and then over here to this, right? Which means that there's a lot of room for those errors to happen. The longer the pipe segment you run, the better. The less calculations has to be run. Just a very, very simple way of going about it. Secondly, okay? Second part is that when you're making manifolds, the second you place one of these in, you split up the pipe segments. Meaning this is a pipe segment that can take 8, and this is a pipe segment that can take 13.3. there's calculations happening. Like there's 3 different pipes here that need to be calculated. You can't really get away from that. If you need 120 machines or 200 machines that requires water, you can't get away from having at least like that number of like split off in your pipes. You need it to make sure that all your machines get water, right? And an easy fix or whatever liquid, it might be like some kind of like sulfuric acid or oil or heavy oil residue or fuel or turbo fuel or whatever it is. So you can't get away from this. But by spacing out your machines and making the pipe segments a little bit longer, you make it a little bit easier for the calculations to happen accurately. So if you do this instead and have a little bit more space between your machines, you are less likely to run into issues. Same thing if you have a longer distance between the split and the machine. So if this, like instead of running this little bit out, instead it runs all the way. Let's say like it runs this like this distance before it gets there, right? Less likely that you run into issues. So that's one thing to do to try and solve if you have flow rate issues. Because these will, like, it might be that you run water in, and then just down here, it looks like, okay, I'm just getting a flow rate of 597 or something like that. Like, you don't actually get the full amount that you're supposed to get. And that's the flow rate issues. These are intentional, and I'm now going to explain why. There's a video that came out a couple of months ago where Snutt, the community manager, or one of the community managers for Coffee Stain Studios who makes the game, where they talked about this. And the flow rate issues are intentional. And it has to do with how we build our manifolds that causes the problems. There is something called water hammering or flow hammer effect, which means that if we run water in here, the water will continue all the way down, but over here is a full stop, which means that the water will hit this end and bounce back. So if you have like 200 cubic meters running in here, 50 needs to go into the machine over here. You have 150 left. That's going to hit here, bounce back, and cause flow rate issues in this segment, right? Which means that you might even get backflow further down the line or causing flow problems. Like it's just gonna be like causing problems over and over and over, like a domino effect, slowing everything down. So how do you prevent it? Well, the easiest way is to not have the flow rate or a full stop here. Instead, what you do is you place in a pipe, like so, that goes all the way back to the start of the manifold and goes back in and then continue flowing this direction, right? And simple enough, no problems, right? However, if there's still too much liquid, like you are running an overflow, or rather like you're still having an issue, the way you go overboard on this, the way you take this to the next level, is making sure that you have a storage that can handle the liquid that is coming here. Like if you still have problems, this one doesn't work, you still have problems, then you build this configuration. Okay? Because then what will happen here is liquid comes in, it's going to split, it's going to go both directions and fill up, and it's going to continue doing that all the way down the line until it hits here. Instead of having a full stop or just a loop, it goes into a fluid buffer, right, through a valve. And when it hits here, it's not going to be able to go back because there is a valve in the way. Like this makes sure that everything can just flow one direction. So when you hit here, it's going to flow around and do the same thing over here. Remember, this pipe is probably already full at this point. So what happens then is that this little bit of flow here actually starts evening out the back, like the hammer effect, meaning that after a while, what you will see is that this liquid that hits here will actually start flowing in to these points and creating a flow that is like pushes primarily this direction, right? So because of that, you will have an easier time getting all the liquids into the machine that you need to, because you don't have the hammer effect causing a backflow in your pipes. And whatever extra liquid you do have that might happen because of it, or while, like, let's say that some of the machines earlier on in the manifold are getting full, so that they're pumping more to the next machine and the next machine and the next machine, then it can fill up here and then just continue flowing around and flowing back into the system with no full stops before it actually hits the machine. Meaning that you won't have that effect and you will save yourself a lot of problems. So while we, like I said, like try to use as few of the valves, the pumps, and the floor holes as possible, this is basically like the necessary evil to fix it. Like if you're gonna have problems, like try replacing them, like removing them, placing them back in again, or something like that. Sometimes just reloading a save helps, whatever it is. However, now I've been playing on my beginner's guide series, where I have just like I'm like 80% done with building a massive turbo fuel power plant that uses a ton of pipes. There's a ton of liquid being moved around, and I have started putting in these like loops and everything, but I haven't been able to completely change the plans for how I build. However, I've learned some stuff building this that I will take with me into 1.0, because while Coffee Stain is talking about solving this flow rate issue and changing the mechanics, they might not, and it might be a while even after 1.0 that we get to see that solution. So what have I learned and what will I do? Well, number one, I will start making this instead of this. Number two, instead of this, like configuration for machines, like placing them as close to each other as possible, I will start spacing them out. And when possible, when it's not like hundreds of machines, I will probably have like even multiple spaces like this in between them. So what I will also be doing, and this is to prevent me using pumps, having to use valves, having to use like a bunch of floor holes and stuff like that. Basically, to reduce the number of uses of these more buggy items is, and also to prevent flow rate issues, is I will probably start building from the top down instead of from the bottom up when I'm dealing with liquids. So I will probably build something like this, where I have the water tower I talked about before that goes up, and then when it hits the peak here, I go down and I start building my factory like so. So I have my like manifold that moves the liquid into the refiners, and then because I have it like this, what will happen is like I said before, the liquids will try and like they will try to find the lowest point, so they will flow down towards the machines. But I will also prevent any of the like hammer effect or hammer flows, because I've put in this fluid buffer like loop that goes back, and because of the heavy high lift or great like head lift there, it will go down, it will go around here, and then it will go back up again. And something like this is also something that I would do. I would start the machines without this here, so that we get to see all of this happen, right? And all the pipes fill up. And then afterwards, then I will place in this final pipe, right? Or if I'm really paranoid about getting like backflow and like sloshing problems and everything, what I would do is I would go and I would place simply like so. I would place in these valves that would be preventing any of this liquid from going back into the pipe. It can only flow this direction, right? That would solve that problem. I have to experiment more with it, of course, but this is how I would do it on the input. Then for the output, I would look at how can I make my pipe segments as long as possible so that I have fewer of them, right? And in this case, just because I'm simply using 3 machines, I would run them all into a single junction here, right? And then run them over, run them down. Remember, now they have this level of head lift going into these machines, where I would probably set up just the same kind of like thing here, where if I'm paranoid or I notice that it doesn't work the way I would want it to, I would place in these 2 valves, reducing, so like in this setup I only have 1 pump, and if need be I would have the valves. Like and something that I could even do with this, and this is like I have to experiment with this to actually figure out exactly how it would work. What I would attempt, and this would be on my experimentation like docket, I would say, is I would probably see if I could place the fluid buffers like so instead. So they come in there, boom, and I would make them run up. That doesn't look very good, but let's just go with it. And because I can't be bothered fixing all of it now that I'm just doing a demonstration here. So with this, I would basically make it so that liquid that hits here, it will be able to travel up, but it won't like flow back, or have a lot harder time flowing back. It will like travel around and then go back out here into these into the manifold. So yeah, that's basically like how I would experiment. I would try around with like where to place the valves. Like I've had in the past, I did this. Let's see, where is it? Number 7 is my hotkey. Where I did this between every machine to create, like, to prevent the blowback or the flow, like hammer flow. Not, it wasn't really effective. So I would actually, like this, I know from using it, this doesn't work. The best way is create this little like isolated flow around ecosystem where you have no actual full stops that isn't just like going into the machine. If it is going into the machine, then it's fine because then it's being used. That's where it should be. If it's like a full stop anywhere else here, that would cause the problems. So try to avoid that, and you're probably going to be fine. And you can do this in different ways. Like this is one way that I've seen it done. Another way that I've seen people do this is that they go like a full like loop around like this. Let's see if I can actually make this look. Let's go like this. Here, where you have like a loop around from this, because then like this is not a full stop. Like experiment, see what works for you. The only know that this setup is going to cause problems. If you have flow rate problems, it's going to be because you're doing this, right? Or it's going to be because you are trying to move it flatly like this instead of having a flow down to your machines. This one is probably one of the better ones where you have like a slight down, or even if you start like up here with the manifold on this level and then run them down, if you are willing to risk it, like conveyor holes or pipe, like these ones, pipeline floor holes, or just have like an open space. Like you can do exactly whatever you want, like your game, have fun. But if you are messing with fluid dynamics, basically think how would a liquid react in real life, because they've made the liquids pretty realistic. So if you take like 2 glasses of water and you pour them in a sink on one end, like one end here, one end over here, and you pour them at the same time, they are not going to like just phase through each other in the middle. They're going to hit and they're going to counter each other in the middle, and they're going to neutralize each other's flow. Liquids will try and flow down. Liquid will try and fill spaces. Liquid will do all of those things, so treat them as such in the game. So another thing that you can do, very simply, if you're not finding a solution to any of this, right, that is reduce the number of machines, right? So if we look, I've put on a recipe here. This needs 30 crude oil per minute and produces 40 heavy oil residue per minute. Ignore this, this would be sunk or something. This is physical, we're looking at liquids. If we are looking at this, it creates 40 per minute, which means that this is what we need to look at in terms of how big we make the lines, not the in, the out. So in the out, this means we can fit 15, I think. If we make a multiplier, 15 times 40 is 600. That's a full pipe, okay? That's fine. However, let's say that you're then, and once you're done with that, you're running that in here, right? Which means that of that, those 15 machines make 600, and you run them in here, and at the maximum, you can have 10 of these machines lined up at the same time. Don't do that. Run 9 or 10 and underclock the last one 50% so that it actually doesn't use the full amount of that 600. So you give yourself a bit of a margin, like there's like if you're not gonna get the full flow rate, don't calculate and build and overclock or underclock based on that flow rate, okay? That's basically it. That's what you need to be keeping in mind. That's what you need to look out for. Like if you can't fix it with like how you build your manifolds or anything like that, don't plan and build with the intent of using the full capacity of it. There is an exception where you kind of have to figure it out, and that is for the let's see, where is it? It's for this little boy, the nuclear power plant, because they use, without any overclocking, 240 cubic meters per minute. If you overclock, that number goes to 600. You need, per machine, you need to have a perfect 600 coming in, which means you have to figure out all of this and how this works and make sure that you have flow rate working properly. If you don't overclock that much, or don't build nuclear power. That's it. Because if you try and you don't have that flow rate perfectly figured out, you are screwed. A different alternative to reducing the amount of pipes and everything that you have that will mess with you is to use packaged water instead. So instead of having this running into like a manifold and over to a train and then being moved around or whatever it is, instead of that, you run this water into a packager. So you move the water, let's see if we can get this. You move the water into production packager. You move your water into a packager, like so, where you package all the water, and when it's packaged, move it on a conveyor belt into the train, move it wherever you need it to, and then on site, just before the manifold starts, that's where you unpackage it, and only then, because that means that all of those transport pipes, all of these long buses, all of the things that could go wrong, you reduce that to a minimum. So that's like the final tip. Like if you have the resources to have all that packaged water, do that. And a good thing to do there as well, like an easy thing to do, is recycle these. Like they don't, the empty canisters are not destroyed, so you can easily just like package them into like the same train or a different train or like on a different belt and move that back so that you don't have to constantly produce thousands upon thousands upon thousands of canisters. Instead, you just recycle them, send them back. The only time you need to do that is if you're sinking the liquid. Then you need to make new canisters. Because the only way to sink liquids is by packaging them and then sending them into the awesome sink. So that is it for me. This is the basics of like what are you doing with liquids, how do they work, what do you need to think about, and how would you place like pipes and stuff like that. Now, would this work? We'll see. I'll have to experiment more with it. This is just my tips based on the mechanics as I have understood them, based on the something like 30 or 40 hours I've now spent messing around with water, oil, like crude oil, heavy oil residue, fuel, and like all of that stuff in the massive 50,000 megawatt turbo power plant that I'm building in the beginner series. And I just came across Jeffrey Place who mentioned this, and I was like, okay, let's try that out. And I noticed that it worked pretty well. And then I went and found the actual clip that I will be linking in the description where Snutt talks about how the fluid mechanic works. And a great tip for figuring out how to deal with this is actually look up how fluid engineers, like drainage engineers and similar, actually deal with hammer flow or water hammering. And you will find new and creative ways of solving your flow rate issues. And hopefully, we either get a really good tutorial, like in-game tutorial for how to build this, or we get a change in the mechanics that helps us make our 100% efficient lines and everything. With that said, I have no more to say on this. Go forth and do your best, and if you run into any problems, if you want to troubleshoot and everything together with me, or in the other people in my Discord, there's a link in the description. If you like the video, show that with a thumbs up. Subscribe to the channel if you want more of this. There's a lot of nice tips and tricks now in the playlist, and we are moving over to 1.0 in September. I will also be starting streaming and like all that kind of stuff. So we are going to have a lot of fun together, and I won't be I won't stop making Satisfactory content because the community on YouTube and for the game in general is awesome, and I just feel so happy to be making content for you guys. So with that said, have a great day. Bye.